So I'd like to, after that brief introduction, I'd like to introduce our first speaker, which is our first keynote. I've already mentioned his name, Joseph Halati. He's a bit of a serial entrepreneur, but one of the more remarkable things he did in 2018 was to combine Lidar plus accurate geopositioning, mounted on a truck, and use it to capture the location and a lot of other information about underground pipelines. And he's going to talk today about what impact that technology has had on the pipeline industry. So Joseph, floor is yours.
All right, thank you very much, Jeff. And that was a great opening presentation. Tech support will let me know if I'm just talking to my screen or if you can actually hear me. But as always, Jeff, a great presentation really covering the importance of mapping underground utilities, what the future holds. And there is a lot of exciting stuff going on in the mapping industry in general, but particularly for underground mapping. And I think you'll see that from Lux Modus's perspective here, we've invested a ton of money and time in this because we believe that it's an important societal goal, but also the world is ready to actually receive 3D mapping and wants to consume it. And all the other speakers that are coming up have great technologies as well. And we look forward to some of our data someday showing up in some of their technologies. So I'll just share my screen here and start my presentation. I believe you all can see it. If you can't, tech support will provide me a message in the chat. But yeah, thanks again, Jeff, for the presentation and asking me to present here at the conference. We're pleased and honored to be able to present at this conference, a very forum, I guess, really, but a really important topic to us, a mainstay of our business, and myself, something that I've been involved in pretty much my entire career. As Jeff mentioned, my name is Joseph Halati, and I'm the president and one of the co-founders of Lux Modus. And we are a 3D mapping company, as Jeff alluded to, and I'll get into that in a little bit. I have a few slides that Jeff also more or less covered, but talking about the importance of underground mapping, utility mapping, and why we are in the business of doing what we're doing. And that leads to, that's going to lead to the point of why Lux Modus does what it does and how it does what it does. And you'll see that in our introductory slide here. We call it democratization of 3D mapping for underground utilities, and we believe that's one of the future growth spaces for our industry. You can see in this image on the right, that's our system. That's what we call our Lux Gear system. To give you some context, that blue box is about the size of a small shoebox. Between those two antennas is 1 meter, so it's actually a pretty small system encompassing an ultra high density LiDAR and 3 ultra high resolution 13 megapixel cameras. It's a completely self-contained system, but I'll get to that in a moment. But that is us actually out just a few months ago in Northern Canada on a pipeline project using our automated mapping technology. Jeff mentioned digital twin. Lux Modus is proud to be one of the groundbreaking members of the Digital Twin Consortium, which is a not-for-profit organization helping develop standards for organizations to develop digital twin capability. And infrastructure is a major vertical in that organization. And if anyone would like to know more about it, please feel free to message me afterwards. I'm happy to talk about the Digital Twin Consortium and how, whether you're a public organization, a business, or a not-for-profit, how you can be more involved or participate in the Digital Twin Consortium and learn more about it. At a minimum, the consortium provides guidances and not standards, but guidances on digital twin and what it means. And the Digital Twin Consortium works with other organizations as well to help develop standards. But to move into the presentation here. Oh, I can't seem to advance my slide for some reason. There we go. There we go, caught up to me. All right, so about Lux Modus, that's a different pipeline project. Actually, that's from the fall time. But again, that's our system out on the right of way collecting data. The Lux Modus, basically, we are a rapid high volume 3D mapping technology company. We are actually ourselves not a field data collector. We have partners and customers that actually buy our equipment or rent or lease the equipment and go out and do the collection. We partner with field services companies, survey companies, First Nations companies out there that are providing services on construction projects, a wide range of partners that go out and collect data. But our biggest partners are really the system operators and the survey companies that service those service our infrastructure. We're focused purely on the technology. We manufacture the collection platform and process the data. Our true mission in Lux Modus, though, is just to democratize 3D mapping. So it's just not for pipelines. That's where we started, because we believe that's actually the hardest use case, and that's kind of the topic of today. But we are now expanding to all the other sectors of rail, power transmission, particularly urban mapping in general, and rapidly mapping, making 3D models of cities here in Canada, now in the United States, and soon in Europe. And we are driven to be the fastest, cheapest, most effective way to produce better 3D maps of the world. But why do we need 3D maps? And this gets into the crux of the problem for underground utilities. And it's because the world needs 3D maps. There is a gap between the physical world, that's all of our infrastructure, our buildings, our roads, our sewage plants, everything we have in the physical world that we live in, and our societal goals. And Jeff mentioned a few of those. One of those is we have to do better at reducing and eliminating ground strikes and people getting killed and injured and great property damage occurring because of utility strikes and just generally not even knowing where things are. So the world's now used to 2D maps. I remember when Google Maps and MapQuest, for those who can remember it, first came out. My colleagues and I in geography all thought it was a great thing because the world's going to get more exposed to 2D maps and the importance of location. And now that that's a mainstay in society, I think the world is changing to where people now want 3D maps. But we know, all of us in this infrastructure industry know that we need accurate 3D maps to do our jobs better and to meet the requirements. All right, see if I can advance the slide again. All right, and that's where we bring underground mapping to the forefront of the discussion. We continue to urbanize and densify. So places that weren't really urban before are small towns. I grew up in a small town in Alberta that was like 8,000 people when I first moved there, and it's now like 30,000 people. The cities that we do have, they get more and more dense. Here in Calgary, where I live now, 4 and 5 story apartment buildings are being torn down, and 20-story apartment buildings are being put up. With that comes greater demand on the utility infrastructure. As many of us know, older infrastructure is now coming to its end of life and is either abandoned in place or needs to be replaced, and there's projects to do that. There's increased complexity in the utility landscape. It used to just be, we were getting sewage taken from our homes and water brought in, and then we got gas, and then we got telephone lines, and it's just, as you can see from the picture on the left, just an increased landscape. I also personally believe, I don't have any stats on this, but I believe that there's a lower public tolerance for interruptions in utilities. As I mentioned, growing up in a small town, the power went out probably once a month for an hour or two from time to time, and that's just the way that it was. But can you imagine in downtown New York City right now, or downtown Toronto, really, or anywhere, if the internet went out for like a few hours or something like that? The world would lose its mind. So really, that tolerance and that expectation on our infrastructure just continues to grow. I'm sure all of us have seen the importance of safety increase in our careers. I'm really glad to see it. It's an absolute standard now. There's no question, and companies and the public, particularly legislation, is expecting that there is no excuse for death or injury on a construction site, and it's not tolerated. And that's a good thing, but that puts a requirement on us in the mapping world. Let's see if my slides are really slow to advance here. There we go. Anyways, that being said, that brings us some pretty specific challenges, and I think we will all agree that they are universal. Jeff has touched on these, but generally we seem to always have insufficient, inaccurate, incomplete, or completely absent historical data. That's from when stuff was built in the past. We didn't save anything or keep anything, but also now, as Jeff alluded to, which is a frustration, that we go out and line locate something, but then it's just for that one project and no one actually captures it. I think that's beginning to change, though. Utility projects compete for resources and money with other projects. Dollars are tight as tighter than they ever have been before. So there's a strain on, there's a pressure on to have really good data, but do it quickly and accurately, but at a low cost. Time is of the essence. Everybody expects great data, but the pace of construction projects, because of densification and people not tolerating blocked traffic and so forth, you know, that causes, that puts a lot of pressure on us to get out there, get mapping, so that the engineering companies and the construction companies can do their work. Jeff mentioned that not knowing what's underground is probably the leading cause of construction delays, and I have no doubt of that. Again, the focus on safety and to create a zero incidence environment is a pressure on us. And while we're out there on the roads and sidewalks trying to find things, it's hard to do, but it is an important goal. But those challenges together, you know, speak to that original point of we have the physical world and we have societal goals, and we need to really bridge that. And we think the best way to do that going forward, especially with the time crunch and cost crunch, is with technology. But I'll mention another big challenge that I think I'm seeing growing, and that is expectations. You know, like, are we mapping in the modern age, or are we? That's kind of my my tagline. And there's a lot of expectations, particularly from millennials. And I've heard this from many business development people, and that is the phrase, "Is it unreasonable?" And I think that's the way millennials think. And I'm not an expert, but you know, that's kind of a personal observation of mine. They think, is it unreasonable for me just to have a rich data set? Why can't I see where everything is on my iPad? You know, how come this data set doesn't go into this piece of software? Or why is that just in Excel and not in a relational database? And why do I have to use this piece of software or this device to consume that information? They want information in you know, to be interoperable, portable, work with different systems, and be available in different mediums. And I think those are good expectations. Ultimately, though, I think the underground mapping industry faces two major challenges, or we can categorize them in two ways. And I don't want to belabor these points, but the first is that we have either old data or no data. We all live this. That's part of the reason why we're here. There's no actual data. Data we might have is analog. Stories tend not to be available anymore. If I go to a field server, a plant out in the wilderness or part of downtown Calgary, and the construction foreman that was there, or the manager of that plant that was there when it was built, or when that line was put on, he's retired like 10 years ago. So the ability to rely on guys who work at a certain people who work at a certain place to tell us where something is, that's actually kind of gone away, I think. A lot of missing markers and signage out there. I'm sure a lot of you have experienced that. And of course, as assets transfer from one company to another, the information gets lost. So one of the ways I think that we're dealing with this in our industry is through intelligence. And we have several great speakers speaking today and tomorrow about this, about using artificial intelligence, but of course we still have the human intelligence. And that is using the proxy data that we have out there and that good old mapping gumshoeing that I call it, just like a police officer going out there, putting 2 to 2 together saying, oh, the manhole's over there, the sign's over there, so it's gotta be somewhere in here. That's an important part of the way we do our work, and that's not gonna go away. But as I mentioned, there's a lot of software and technologies that are out there using remote sensing technologies and compute to solve a lot of this no data issue. The second problem we have, and this is the problem that LuxModus is really tackling, is our current methods. And there's until we have better technology, which LuxModus we believe is bringing to the forefront, there's hard to get around these things. Trying to deal with the fact that there's no actual data, so we have to go out and find it and line locate, as Jeff mentioned, and do digs and so forth. It's expensive, time consuming. When we're out in construction sites or out on a freeway, you know, it can be hazardous. Because we're using basically an analog method to get data into a digital state and deliver to those who want to consume it, that can be very slow. We find things, we do a daylighting and we discover stuff, all of a sudden we're interfering with construction schedule and the public's use of lands that belongs to them. And of course, everything we do out there when we're line locating or doing digs and so forth, it requires special equipment, software, training, and you need expertise to do things efficiently. So that's where Lux Modus comes in. And we believe the solution is to change mapping fundamentally, field mapping. We're not going to get rid of line locating, you know, with a wand and so forth instantly overnight, but we believe that through democratization using technology, we can improve that situation. But to democratize, it means certain things. But essentially, it means making an activity of making or an action making the execution of something accessible to everyone. So I think if we can make 3D mapping easier to do and less expensive, that will increase its adoption. So to make that happen, again, it has to be affordable, even for the most basic of jobs. It has to be easy to use, and being easy to use, then more people can use it. It can deploy faster. Of course, because it's out in the field, it has to be rugged. But one of the most important things is whatever data you create, you have to be able to consume it and ingest it. And I think the best, Jeff put it very well, Lidar is really coming to the forefront, but I would put it that more what we need are 3D surfaces. Lidar is the best way to doing that, but there's also photogrammetric ways. But we need to create basically 3D models of the world that actually have surfaces and depths and are not just relativistically accurate, but they're absolutely accurate. So not just they have a relative position and it's a pretty picture to spin around, but you got to be able to put it in a database, and the crossings need to line up and the manholes need to line up. You need to have imagery and attribution and data management. And to anyone in the geospatial world, that's a given. But when you look at a technology set, a technology platform that integrates all of that together is the ideal solution. There are a variety of technologies out there. Handheld scanners for LiDAR collection and photography are getting better. Some people are even out there with iPhones just going down and scanning and so forth. That is good data collection. It does come with its challenges though, especially when you're doing SLAM and you have to close the loop and you've got relativistic accuracy issues. But at least we're collecting data, and you could at least, send a picture to the construction foreman and saying, hey, this is what we found. I'm really excited about ground penetrating radar. It's advanced greatly in the last few years, and I think it's on a trajectory to really change a lot of the way we do, especially long, complex environment mapping. Of course, locating tools continue to improve, get better, easier to use, and people are getting more familiar with them, so that helps considerably. But tying that all together, I'll be self-serving here and talk about LuxModus and what we've done. We basically developed a very affordable push-button 3D mapping system. And when I say push-button, I mean there's essentially no training required to operate it. It's readily deployable. It's ruggedized. It comes in a case. You mount it, and you can quickly go out and collect data. All the things that you need to do to process that data, we've internalized. All of the post-processing, all of the registration, colorizing the point cloud, making photo mosaics, getting it all into the cloud and getting into GIS systems, we've automated the entire process. We are spun off from the autonomous vehicle mapping industry, so we've taken a lot of that hardcore technology and even workflows to automate 3D mapping. Data, once it's uploaded to our cloud, is turned around in minutes. We use parallel processing, so whether you upload 5 scans or 50 scans, it's literally available on the web within minutes of upload. And once space station data or correction data is available, that's automatically processed as well. So that issue of data delivery, that hey, we found something in the field, what does it look like? It has to go to the engineers or construction company. That's available in minutes. And back to the data management point, all of our data uses industry standard formats, so it can readily go to any geospatial or CAD system for use. On a side note, I'm talking to a couple of the companies that are even presenting here. Our technology can also be used just to complement the intelligence-driven locating methods, where instead of scanning the actual pipe in a ditch or whatever ditch is open, just the fact that we can drive around a neighborhood and scan everything in 3D and have all this photography, that information can then go into intelligence systems to do automated extraction of where the manholes are, fire hydrants, power poles, and so forth. So I'm just going to give you a few examples here. I believe I have a few minutes left. This video is of a pipeline project we did a few months ago. The first you saw, of course, the heat map representing the elevation. Then we, of course, colorize the point cloud using the photography. And you get very high resolution. Unfortunately, when we converted this to a video to show in PowerPoint, a whole bunch of the pixels disappeared in that. So those aren't actual, that's not corrosion in the pipe. I can assure you, it's a brand new pipe. That's not actual corrosion, but something happened in our video conversion. But you can see the value of having this information. And of course, because it's LiDAR, you can do measurements, you can put it into CAD and GIS and measure. If you shoot a gap under one crossing, you can do those measurements. You can see, hey, is there material collapsed on it? Is there stuff left in the ditch? You can even read the writing on the pipe in our imagery, so that you can do quality control on your attributes. This is all processed automatically. So we've taken all that, the cost of the software, the training, the expensive geospatial professional and so forth, and that schedule to get data delivered, and we've eliminated it. Basically, our fee-for-service costs, our SaaS model, is you basically pay for linear footage or meterage of data processing, and that's your cost. Whether it's whether you take 5 minutes to scan it or 50 minutes to scan it. If it's 100 meters, it's 100 meters, and it has blank cost, and you have no software costs, no training cost, and you get your data instantaneously. So when it comes to democratization, well, that's really what I'm talking about with LuxModus, is our ability to make it accessible for everyone, so that on site, that a construction company, an engineering company, a survey company can have another tool in their toolbox that's, as we say, affordable. It's really easy to use, and even though we're adding another tool to your toolbox, there's not a whole bunch more training you have to take. There's not more software you have to buy. And it's as a fee service, unlike the traditional time and materials while you're in the field. Democratized technology inherently is a fee for service. So that's a disruption to our industry as well, is that if we know we have X amount of linear meters of infrastructure we're putting in to as-built that, or to make your geospatial component of the digital twin, it only costs X, regardless of how many hours a person is out in the field. The rapid mapping and processing is a great it's very advantageous to the engineering companies and the construction companies, because they're actually getting real-time information. So the other big component, though, is that I, as a geospatial person, really like about our technology is its interoperability. As I mentioned, our data goes into standard GIS and geospatial formats. So any one particular company that has its own viewer or their technology for managing a project, or educating the workforce of what a certain condition is and so forth, it can go into those systems. You don't have to use our system. We don't have a proprietary viewer. We're here to enable the survey companies and the engineering companies and the engineers at the city and so forth to be able to consume this data easily. And I think probably the most important thing is we strongly believe that we're increasing safety out on the construction site. Is that going to create your digital twin? You quickly go and scan it. You're done in minutes, and you're gone. You're in a vehicle, whether it be a side-by-side like a UTV, even on a bicycle or a golf cart, or inside of a truck. You're not walking out on the highway or through the forest kind of thing on your own. You're in a vehicle. You're safe, and you're done in minutes. And I hope that we never get proven wrong with that, and I hope there's no statistics really, because I hope no one's out there getting injured. But philosophically, we believe that it's a much safer approach to 3D mapping. Ultimately, though, for the key takeaway for democratization is lower cost and increases adoption fundamentally with any technology, and increased adoption of a digital twin approach or reality capture approach to mapping utilities will improve the data for underground utilities. And it's just not the one thing you installed. Think of all the other information you're getting. Every time you install something, you're finding crossings, you're finding other information. And once we capture that, all of that data, and we manage it together, you're updating other data sets that you have, hopefully, if we're doing our data management properly. Sorry, just trying to get my slide to advance here. It's there we go. So what does the future hold? I believe that the rise of intelligent locating, these technologies that are out there, these software companies that are out there using AI and satellite imagery and so forth, are going to have a profound impact on planning, construction, and engineering projects, as well as execution. Our democratization and others of 3D mapping, I think is going to have a profound impact on the industry, where more people are out there collecting data. The more people you have collecting data, and it's very current, that improves the data landscape considerably. Because we're producing digital data, not analog data now, that data should be getting saved, and and remain in the record forever. So through attrition, through time, we should have much better data for the world. Increased interoperability increases consumption and raises expectations for the use of digital data. And I think raising expectations is good for our industry. So I'll just go back there. Oh yeah, ultimately, there's no more excuses. Once you have digital data, there shouldn't be any excuses of why something's not being used. For someone to say, well, I didn't know that was there. Oh, really? Well, here's this database, it's in 3D, you could have looked at it. And I think that expectation will impact how the world perceives how we do projects. I don't know how much time I have left here, but this is just my summary slide. Just these two images here, these are from LuxModus. This is actually just from a few weeks ago on a pipeline project. As I was mentioning crossings, that's the Lidar from our viewer, our online web viewer for recently collected data. That Lidar point cloud unfortunately hasn't been cleaned up, but you can see the basic information you can readily extract in the Lidar. Obviously, feature extraction could be done from that. We automatically, in pipelines, our system automatically extracts top of pipe and automatically classifies the Lidar into bare earth and pipe and so forth. And obviously there's all the imagery that goes with it. There's in that particular spot, there's that crossing that we have. And again, those are all not just geotagged, but geo-orientated imagery. So you could put them into 3D visualization technologies, VR and so forth. I think, I'm not sure how much time I have left, but I would like to leave it open up for some questions if there are any. Of course, you can always email me after. There we go. There's my slide advance. My email address is joseph@LuxModus, all one word, .com. And of course, you can find me on LinkedIn. I'd like to thank Jeff again for inviting me to participate and to speak. And I'll open the floor to any questions. I think I stopped sharing there. How's that, Jeff?
Okay, that's wonderful. Joseph, thanks a million for that presentation. I mean, I think that gave people a real perspective on what's happening in this sector right now, and how the new reality capture technologies and other technologies are really changing how things happen. I think we have time for just a question or two. I had one, and it really it comes down to, I know that at one time PHMSA requirements for accurate location of pipelines was like on the order of 100 feet, Yeah. So the question I had was, what motivated the pipeline companies to adopt this high accuracy LuxModus technology?
Well, that's a really good question. And of course, we are still a young company, and we're still trying to transform the industry. Not every pipeline company in the world is using us yet. We hope someday they do. But for the ones that we are working with and the adoptions that we have got, there's a couple of factors. A is fundamentally to reduce mapping costs. Move a lot of it to the desktop. If you scan the pipe in the ditch and you have the top of pipe and you can see all the welds geospatially, you don't need to go out there with a pogo stick and survey that top of pipe. That increases safety, but it's a huge cost, especially if you're in Northern Canada or you're in an urban center where you're blocking traffic in that and you're trying to map something. It's a huge schedule and cost, and there's a huge safety component too as well. The other perspective, to be quite frank, is the societal part. I put up that slide about physical world and societal goals. The world, and I think it's a good thing, society is now not tolerating not knowing where things are. First Nations want to know what is on my land. I was in the EPC side for a long time. We'd go and talk to stakeholders, whether they're First Nations or a local community, like a small town, and you go to an open house and you give them an alignment sheet, and they're like, and you give them an as-built. They're like, okay, well, what is this, right? Now the fact that you can put it in 3D, show them, and with a measurement tool saying, hey, we know this is near your barn. This is how far it is. You use a little 3D tool. It's this far underground. We said we'd be X amount away from the river. This is where it is. It allows the public to consume where things actually are and demonstrate, like we produce, I think, the best infrastructure in the world. At least as a pipeliner, I can say we build the best pipelines in the world. The craftsmanship that goes into our construction is world class. We just haven't been able to prove it or demonstrate it before. That's one of the main drivers is public consultation, to be frank. Then the other one is that, hey, there's certain data we do want. We want welds to be within kind of 2 inches, but let's use technology to reduce the cost and safety risks of having people in the field.
Okay, Joseph, thanks a million. There's a number of other questions here, but I'm afraid we've just run out of time. So we will have a 10-minute break. And again, Joseph, thanks a million for this. I think this is just, it really sets the stage for everything else we're gonna be talking about. So we'll be back in about 10 minutes. Actually, now it'll probably be back in 5 minutes. So we'll be aiming at coming back around 10:55. Thanks again, Joseph.
Thank you. Sorry for going over, folks.
No problem. It's worth it.
Yes, thank